Okay, ladies and gentlemen, we have talked about points, lines, planes. We've taken those lines, we put them into angles. We've taken the angles, we've taken the lines, we put them into shapes. Those shapes we have turned into polygons. Those polygons we've made into polygon family tree. What we're going to talk about now is we need to move into the third dimension. So that's what we're going to do right now. Now you'll notice I have GeoGebra pulled up. What I have is I have a non-regular figure here at the base. Now, I will tell you ahead of time that I am cheating a bit because I will be drawing in perspective on what is otherwise a two-dimensional shape. So the program itself will see it as two-dimensional, whereas I will be drawing it in perspective for 3 dimensions. But that doesn't really make too much of a difference for our purposes, but it does allow me to move some things around. Now, the first thing we need to talk about is a prism. So if I'm going to talk about a prism, we probably ought to put it down somewhere. Here we go, prism. Now, the next thing we're going to talk about after that, we're going to talk about a pyramid, followed by a cone. Actually, we'll probably talk about a cylinder, followed by a cone. And if we get around to it, we will take care of a sphere. So we'll go ahead and put those guys up there right now for us. Now, for a prism is a two-dimensional shape stretched into 3 dimensions. Now, in this case, I'm going to copy the figure. The reason I'm going to copy the figure is because we're going to take this figure and we're going to move it up and just like stretch it in 3 dimensions. And as long as I stretch it right up here and connect with segments, we now have a 3-dimensional prism. In this case, it's probably something near trapezoidal. At best, I could say it's a quadrilateral prism. But if these 2 lines are parallel, it would be trapezoidal. If these 2 segments here were, in fact, of equal length, they would be also known as an isosceles trapezoidal prism. So it's named by whatever the base is. Now, this happens to be a right prism because each of these angles down here is approximately 90 degrees. However, I can have what's called an oblique prism, and that's where instead of the shape going up straight at 90 degrees, it goes off at an angle. So it's like, okay, so we have a right prism. Now, if I were to do the same thing with a circle, and I were to move it straight forward or straight up and connect the dots. Now, technically, I'm using foci, not points on a circle, but you'll get the idea. All right, with that, what we have is we have a cylinder. Now, that cylinder, in the same way, can either be a right cylinder or it can be an oblique cylinder. And so we need to be careful of how we work these. Now, we don't always have prisms or cylinders. They don't always go straight up with same dimensions. But the key is, whatever a prism or a cylinder has, the top and the bottom are the bases. They have to be congruent. Now, I'd like to rotate this all the way around, but even if this were sitting flat, you would still have a base here and here, even if it were side to side, because it's a matter of what's congruent that determines which ones are the bases. Now, if I have, on the other hand, not this, but I move them all to a single point. Now, instead of a cylinder, I have a cone. Likewise, if I come over here and move all these to a single point, instead of a prism, I have a pyramid. And this happens to be a trapezoidal pyramid. So we have cones, we have cylinders, we have prisms, we have pyramids. All of those things are true. Now, for a sphere, that becomes a bit more challenging for me to represent here. I mean, it can be done, but we're not going to worry about that at this point. Let's flip over to right here, and they give you pretty good example drawings of each. So prisms, regular pyramids, cylinders, cones, and spheres. Now, you will need to memorize all of the surface area formulas and all of the volume formulas. You will also have to know what each of the letters means. Pretty much it would be mighty easy for me to take out all of this material and simply give you that and say, give the picture, give the surface area, give the volume formulas. Just saying. Now, let's go flip back over here and let's talk about something. We already know that point C down here is a vertex because it's the vertex of an angle. And it has a side here and a side over here. But if we become part of a polygon, those sides now are a connected portion of the bottom polygon. But in a prism or in a cone, in a three-dimensional figure, this is no longer a side, it becomes an edge because it's where two planes come together. It's where this triangular plane meets this trapezoidal plane. So you need to be careful that you have vertices, edges, and the shapes formed by all the edges are faces. And we have actually a little formula. It's called Euler's formula. And it is faces plus vertices equals edges plus 2. That is the formula for Euler. What it says is if I count the number of faces, 1, 2, 3, 4, don't forget the one on the back, 5, the one on the bottom, plus vertices, 1, 2, 3, 4, 5. So 5 plus 5 is 10. It should be edges plus 2. 1, 2, 3, 4, 5, 6, 7, 8. 8 plus 2 is 10. 10 equals 10. And that works for three-dimensional solids. Now, there's also another type of three-dimensional solid that's worth mentioning, and that is a Platonic solid. A Platonic solid was, of course, popularized by Plato. I don't know that he was necessarily the first guy to come up with it. Most things in math that are named after people are the result of the work of many people. But a Platonic solid is formed by regular polygons. So everything in here is an equilateral triangle. Everything here is a square. Everything's equilateral triangle. Everything here is a regular pentagon, etc. And so these Platonic solids made of regular figures are kind of specialty. Real quickly, looking at this figure, you'll notice even though it's sitting on a rectangle, this prism has a base of GHI and JKL because those are the two faces that match. Something of kind of importance there. All right, so with that, we have all sorts of homework to do. This shouldn't be that terribly new or interesting to you, so we should be able to do the homework without too much trouble. All right, thank you much.